Hello everyone, this is Hajing Tian. This video we are learning chapter 5.2 verifying identities. An identity is an equation that is always true for any angle. So for example, the identities we have learned that sine theta squared plus cosine theta squared equals 1. And also we have learned tangent theta equals 1 over cotangent theta. So in 5.1, we have mentioned a lot of the trigonometric identities, but we cannot cover every identities because the ones we have learned are all the fundamental identities, but later we have some different form or different shape of the identities. How to prove that is one identity? How to prove the left-hand side equals the right-hand side? Okay, so this chapter 5.2 is the verifying identity. We want to prove our left-hand side equals the right-hand side. Okay, here are some methods. First one, we can pick one side of the equation to work with. This is the first step. And usually it is the best to start with the more complicated looking side. So prove, so more complex side equals the simple side. Maybe I'm starting from the left-hand side, for example. And prove this one. And then step by step equals the triangle. This is the right-hand side. Then we can say, oh, this is a identity because my left-hand side equals right-hand side. This is a true statement. It is an identity. And step 2, use the fundamental identity to change it look like the other side. For example, so maybe both sides looks very difficult. The one side looks like this, another side looks like this, and they looks very different. But I can say that left-hand side. So for example, I copied my left-hand side equals the some steps equals triangle, and then my right-hand side. For example, this one. And I proved that also equals a triangle. So a triangle equals triangle, left-hand side equals right-hand side. This is also an identities. All right, some strategies to try. So we may use one of them or some of the identities to prove my identity. So for example, rewrite everything to be term of sine, cosine. So not always we are doing this, but if we have no way, we can try to convert everybody to the sine and cosine. Second, use Pythagorean identities we have learned in chapter 5.1. And next one fraction. So you can split one fraction into two fractions. You can also maybe combine two fractions into one fractions, but make sure you want to prove the left-hand side equals right-hand side. And the next one, two fractions, maybe you can combine them. And complex fractions, try to converting it into simplified fraction by multiplying the LCD of all the mini fractions. Factor difference of square. If we have a squared plus b minus b squared, what is that? Conjugate formula, that is a minus b times a plus b. So in my previous semesters, my conjugate formula is a squared minus b squared. So I put the a plus b first. It doesn't matter which one goes first because they are factors. A plus b times a minus b. Next one, three terms, factors like trinomials. Next skill or strategy is multiply. We can distribute, we can FOIL if we have multiplied trinomial or binomials. We can do the FOIL. We can also do the distribution. All right, let's see the note. Verifying identity is challenging and takes a lot of practice and patience. So do not give up, because sometimes you are almost there. If you give up, you miss the points there. So at least you try a little bit. Then you will see, oh, we're almost there. If you cannot prove left-hand side equals right-hand side, maybe you can try to prove left-hand side equals something and right-hand side equals something. If they are equal, they are also, we can prove this is an identities. All right, let's see the first one. Cotangent theta over cosecant theta equals cosine theta. So which side is more complex? We start from the complex side. It is the left-hand side, we can say. We start from the left-hand side. Left-hand side has a cotangent, has a cosecant. My right-hand side has a cosine. That means I can try to convert my left-hand side into the sine and cosine, and then convert it to the right-hand side. Okay, so on the top, cotangent theta equals cosine theta over sine theta. The bottom, cosecant theta is 1 over sine theta. And then it's not equal to the right-hand side because we're not there. So what is that? KCF. Keep the top cosine theta over sine theta. Then multiply by reciprocal of the bottom fraction. Sine theta over 1. Sine canceled. It is cosine theta. Is this my right-hand side? Yes, it is. Equals right-hand side. Yes, I proved this is an identity. Number 47. What is our left-hand side? Okay, our left-hand side, it is a complex expression. I want to convert the left-hand side to the right-hand side. On the top, what is 1 minus sine beta squared? We know that we want to convert all of them into the expression of cosine. So if I have sine, I have learned that the sine theta squared plus cosine theta squared equals 1. So now if I have 1 minus this cosine theta, it is sine theta, it's cosine theta squared. Cosine beta squared, And the bottom is cosine beta. Oh, cosine beta squared over cosine beta, it is cosine beta. Okay, this is my right-hand side. We proved this identity. It is true. Next one, we have cosine theta squared times tangent theta squared plus 1 equals 1. So left-hand side is more complex. We start from the left-hand side. You can distribute the cosine theta squared. But when I see in the parentheses, I remember that 1 plus tangent theta squared equals secant theta squared. So we make two terms into one term, make the things easier. So let's convert the parentheses to the secant theta squared. So we have cosine theta squared. In the parentheses, that's secant theta squared. And do not say it equals 1. We're not there. So we continue to prove. And cosine, secant, are they reciprocals of each other? Yes, they are, because cosine will keep the same, cosine squared. And secant theta squared is 1 over cosine theta squared. It is 1. So 1 is the right-hand side. Okay, we proved this identity. Okay, let's see the number 51. So number 51, which one is more complex? Maybe you can start from the right. You can start from the left. Maybe they have the same solution. So let's see. If I'm starting from the left-hand side. Okay, so cotangent theta plus tangent theta. I want to convert them to be the secant and cosecant. So let's try to convert them to be the sine and cosine. So cotangent equals cosine theta over sine theta. And then tangent equals sine theta divided by cosine theta. Okay, if they do not have the same bottom, I need to find the lowest common denominator. So I can multiply the top by sine theta, the bottom by sine theta. Here, times sine theta over, oh, sorry. Oh, why I'm doing this? I make a wrong. So let's multiply by cosine theta, top and bottom, because the lowest common denominator is sine times cosine. And another one is sine theta over sine theta. Okay, what is the top? New top, cosine theta squared. The bottom is sine theta times cosine theta, plus the top is sine theta squared. The bottom is sine theta times cosine theta. And then combine them, because on my right hand side, there is no addition. So get rid of the addition. Sine theta times cosine theta. And do not forget the squared. The top is cosine theta squared plus sine theta squared. What is the top? It is 1. 1 divided by sine theta times cosine theta. So I can separate the sine and cosine. So we got 1 over sine theta times 1 over cosine theta. And 1 over sine theta is cosecant theta. And 1 over cosine theta is secant theta. Is this my right-hand side? Yes, it is. Cosecant times secant, secant times cosecant. They are exactly the same. That means I proved that this is an identity. So you can also try from the right-hand side to the left-hand side, and you have the same solution to prove their identities. Let's see number 53. Which side is more complex? So I think either of the both sides looks very complex. But if I say I still start from the left-hand side, and then convert them to the maybe sine and cosine, because they are so complex. So let's convert all of them to the sine and cosine. On the top, we have cosine alpha. The bottom is 1 over cosine alpha. And then plus on the top, we have sine alpha, and then 1 over cosine alpha. And we need to flip, so use the KCF, rescue the cosine alpha here. Sorry, I made a mistake. So what is the reciprocal? So what is the reciprocal of cosecant? Sine. So put the sine set here. All right. Let's use the KCF. Keep the cosine alpha and then multiply by cosine alpha over 1. Then plus, so sine alpha and then multiply by, rescue the sine alpha from the bottom. I have cosine alpha squared plus sine alpha squared. What is that? It is 1. And it is very simple expression, but it is not my right-hand side. What should I do? I have no idea. So I should start from the right-hand side again. So do not give up. Even you see, this is not very simplified expression, but this is not my right-hand side. Don't worry. You can, this step, I can start from the right-hand side if they can have the same solution 1. So second, this is a secant alpha squared and minus tangent alpha squared. What is that? Do you remember the identity? 1 plus tangent theta squared equals 1. Sorry. Secant theta squared. And both sides, let's subtract by 1. Subtract by tangent theta squared. It is 1. So 1 equals secant theta squared minus tangent theta squared. Oh, that means my right-hand side also equals 1. So left-hand side equals right-hand side. Okay, we proved the identity. Okay, let's see next example. Which side is more complex? Maybe later we use the same method, prove right-hand side, left-hand side equals something the same. Okay, I still feel that left-hand side is very complex. And I see this is the fourth power. How to get rid of the power here? Do you remember the conjugate formula? Is a squared minus b squared equals a plus b times a minus b. Okay, if you remember that, if I have a to the fourth minus b to the fourth, so I know that a to the fourth is a squared minus b squared. Oh, this is the conjugate formula again. You see the power here? Okay, this is a squared minus, plus b squared, then multiply by a squared minus b squared. I can continue to factor the second factor. A plus b times a minus b. I got three factors. All right, if I see this, let's use the conjugate formula. I'm having sine theta squared plus plus cosine theta squared multiplied by sine theta squared minus cosine theta squared. Continue to use conjugate formula factor the second factor. So before we start to factor the second factor, how about the first one? Sine squared plus cosine. Sine theta squared plus cosine theta squared. It is 1. So it is 1 times. Then we start to factor the second factor. That's the sine theta plus cosine theta multiplied by sine theta minus cosine theta. Okay. And then, okay, what can I do? I'm thinking, I can do nothing. So how about I just remain the form, because we are not always having the left-hand side equals right-hand side. Why I want to go back or do not save this? Because look at our right-hand side. It's a subtraction, and my expression is multiplication. So if I only stop here, so I only let the first parentheses is 1, and then I'm having sine theta squared minus cosine theta squared. At least there is a subtraction, and also there is a sine theta squared. So I will not use the conjugate formula again to factor this second parentheses. All right, let's see if I can bring this one to the 2 times sine theta squared minus 1. That's the right-hand side. Okay, we have learned that the sine theta squared plus cosine theta squared equals 1. And on my right-hand side, is there any cosine? No, there is no cosine. Let's convert the cosine to the sine. So in the identity here, let's isolate the cosine minus sine theta squared. So cosine theta squared equals 1 minus sine theta squared. Okay, let's replace this one. I'm having sine theta squared minus, what is that in the parentheses? 1 minus sine theta squared. And then let's clear the parentheses. I'm having sine theta squared minus 1 plus sine theta squared. Yes, I got 2 times sine theta squared. minus 1. Yes, that's the right-hand side. I proved this identity. So remember that, do not give up. When you see, maybe from this step, I got sine theta plus cosine theta times sine theta minus cosine theta is not very close to the right-hand side. Maybe you go back to your previous step and then see from the previous step, if you think the previous step is easier, I can convert this one to my right-hand side. So use your pencil. You can erase your